So one of the big things that's come out of the growth of SSN is customers wanting to do that level of testing in system rather than just on the ATE. So to be able to get the same high level of testability actually in the system as well as having it at the manufacturing stage. So the product that we're just releasing is our In-System Test. This enables the ability to hook up to the SSN network. So the SSN product that's been around since 2020, and being able to drive the test pattern content into the SSN bus whilst the device is in system. So really being able to deliver the same level of high quality test in system as what you're seeing today at manufacturing. And this gives a huge amount of advantage in terms of kind of being able to deliver advanced safety, quality, but all at an in-system level. So Logic BIST has been the go-to technology for in-system testing for probably 20 years. It delivers a really good capability in terms of safety and the ability to test the silicon in system. It does have a few drawbacks in terms of it does add some additional complexity when you're designing the Logic BIST into the device. However, and then it also, because it's a random pattern generation, the coverage that you can achieve with Logic BIST tends to be a little bit lower than what you can typically achieve with deterministic test, and it will also take a little bit longer because the random patterns need to kind of work their way through the coverage and get to that level. So being able to apply deterministic test in system is a huge step forwards, and I think there's still going to be some areas where Logic BIST is the required technology, but in a lot of areas applying deterministic in-system test is really going to add an extra level of quality, the ability to reduce the overall test time, so also reducing the overall cost. There's two market segments that we see real benefits in already. So we have the automotive industry. So automotive ICs will really benefit for being able to run these deterministic test patterns in system, because that enables you to run kind of a full test to meet the safety requirements. The other area that's also really interesting is the area of data centers. So a lot of our big data center customers are really interested in this technology because you can run full deterministic testing of the data center without actually removing any boards. And the like the automotive industry, where there's this requirement for extremely high quality, automotive, there's standards and regulations in place. With the data centers, there's more of a commercial requirement there to have zero downtime. So when the data center customers have got their end customers running processes on there that run for days, potentially weeks, if a part of the data center goes down, there's a big loss there in terms of time and revenue. So it's really important that the data center providers make sure that all of their servers and racks are running at kind of top condition at all times. So being able to kind of take the parts of the data center offline and run these tests to make sure that everything is 100% good is really, really important. As part of the rollout of this new product, we've had a number of early adopter customers that have been using it for a while. We've had silicon out there in the field for a good 6 months now, and we're starting to see results back from those. And there's actually papers already published with those results. So it's proving to be a really useful technology, especially in those two market areas. One of the things with Logic BIST is once it's built into your system, it's built into the system and it's part of the system and doesn't change. When you're applying deterministic test patterns, even if you're doing it in system, those test patterns have to be stored somewhere. So that's one of the small challenges with deterministic in-system test, is there needs to be some memory in the system to store the test pattern data. But if you're working with a big data center, that's generally not a problem. But it does mean that if over a period of time you identify some very niche specific faults that can occur with that data center, you can update those test patterns to make sure that you catch those additional faults. So you've got the capability to update things on the fly and improve the overall quality throughout the whole life cycle of the product. So Logic BIST, as I say, is not going to go away, because there is always going to be that need to be able to run a level of logic testing without being able to store the data. So there's always going to be applications where storing the test pattern data is not viable. The in-system deterministic testing really it's an add-on for SSN. So it really takes advantage of the SSN infrastructure, because SSN provides essentially a connection point, and then we can hook up the in-system test controller to SSN and deliver the test patterns straight through the SSN network. If we didn't have SSN, then the interface to the test network would be quite ad hoc, and it would be very difficult to implement an in-system test solution. So SSN again gives us that advantage of being able to have kind of standardization in the family of products. So with the deterministic in-system test, it takes the quality, the in-system test quality level to that next step. So if there's any concerns about the quality and the safety of silicon for autonomous driving systems, deterministic in-system test will be able to address that. And the other element of that is, with the devices getting bigger and bigger for these automotive devices, because the compute requirements are getting bigger as well, one of the other challenges is to be able to run these tests in a timely manner, so that we can get the chip offline, run the test, bring it back online again. And there's elements of the safety standard that mandate that we have to be able to do that in a certain amount of time. The deterministic in-system test gives us a lot more flexibility in doing that. So for me, focused on automotive, this is definitely a big step towards bringing the test technology to a point where we're going to be able to address the requirements for completely autonomous vehicles.